All right, so we're going to go to the t-test between subject variant. That means you have a between subjects design and two groups, okay? So you have two groups that you're comparing between subjects design. We call this an independent samples t-test. All you want to know is if two means are different from each other. You want to know that you want to disprove, I guess, that the mean difference is 0.00000. Now, our null is that our population mean difference is 0.0000. That's what we're trying to disprove. Our effect size is measured in Cohen's d, and small is zero point 0.2, medium is 0.5, large is zero point 0.8. What does the t statistic tell you? It actually tells you nothing important. Number of standard errors at two means are different. If we assume the null is true, blah, 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 we're not going to interpret that. That's no big deal. But what you need to know is that you get a larger t value if you have larger mean differences, which if that was the only thing, that would be cool, but it's not the only thing. You get a larger t value if you have smaller standard deviations, standard errors, and you have a larger t value if you have a larger sample size. So t is impacted by a lot of things. You don't need to know that. I'm just telling you that. What we care about is the same thing we always care about, p-value and 95% confidence interval, and making sure that non-parametric test doesn't sort of change the result. So what you need to realize is that your data will look like this. You will have a participant who is in one of the two conditions, and you have one measure of their dependent variable. In this case, is anger related to political aggression in this example. All we want to know is, well, what we want to know is there a difference in political aggression across our manipulation of anger and manipulation of happiness? So are happy people less likely to engage in political aggression? Are angry people more likely to engage in political aggression? Now, what you need to realize is that each participant is only in one condition, and they only give you one measure of your dependent variable. Those are the important things. Nonetheless, when we enter the data in Jamovi, one row per participant. Participant A was in the anger condition. Their political aggression was 5. B, anger, 4. C, anger, 5. D, happiness, 1. Participant E, happiness, 2. F, happiness, 1. In terms of your specific variable types, ID for participant, your condition is nominal, meaning they're just different names. What is my prediction? This is going to be important for later. We're going to see how this pans out. My prediction is that people in the anger condition will have higher levels of political aggression than people in the happiness condition. We'll see. We'll look at our data and see what happens. You can actually switch which level is 1, which level is 2. I'm going to keep anger as level 1. And then our political aggression is a continuous variable. Okay. Click t-test. Click independent samples t-test. Our DV is our DV, political aggression. Our IV is our grouping variable. So students t-test, right? Mann-Whitney U is your non-parametric test. That's all you need to know. I want my effect size and 95% confidence interval. I want my descriptive plot. I'm going to find that useful. And descriptives are probably going to be useful as well. There are other things in here you don't really have to worry about. I wouldn't click the mean difference and 95% confidence interval of mean difference because those don't really allow for the easy interpretation that small, medium, and large does. So, if we look here, number 1, what are we looking for first? Our p-value. Our p-value is less than 0.05. That tells us on the normal student's t that our population mean difference is not 0.00 forever. So we've disproven the null. I'll go to the Cohen's d. We found a large effect. Our 95 CI suggests it could be between a medium and a large effect. That's good. There is one difficulty here with the data. This is a small participant pool. You're going to see this, get more participants. But right here, our p-value is non-significant in the non-parametric test. That suggests that lack of normality, outliers, lack of homogeneity of variance could be driving this result. That's why we always run this non-parametric test. Now, it's not too bad. It's marginally significant. If this were my data, it'd be like, well, I'd put it in there and I'd say, well, I think I found something. But ultimately, no one would publish this because the sample size is too small. So that's really what's going on here. You have your group statistics where we have angry people are more politically aggressive than non-angry people. We have the standard deviations are the same, so that's good. Nothing really weird going on in the conditions. And here's our picture of our results. Now, one of the things I want to point out is that this result was in line with my prediction. So my effect size, the sign on my effect size should be positive, which it is. So I don't have to change anything. However, if we go back to our data and I click on my IV condition and I move anger down, what you're going to see is that the sign changes, okay? So I like to do it where my effect size is positive if it's in line with my hypothesis and negative if it's against my hypothesis. So I'm going to switch back the level anger first, okay? But essentially, when you're entering your data, which level you want to put first for the t-test is based on which variable you expect to have the largest mean. So I expect people in the angry condition to be more politically aggressive, all right? But ultimately, we get all our results here. These are all the results we want in terms of the two things. We have our two p-values, suggests we could have a violation of assumptions. All right, and our effect size, 95% confidence of effect size suggests between a medium and large effect with a large effect in the sample. Okay, this will help you make your own graph. You can't publish this graph, but this will help you interpret your data. Were you in the right condition? Make sure that your effect size sign is the right sign.